You did it quickly, the way you do anything that seems straightforward. You were working along the fence line, clearing the dead stems from last season, and there it was, attached to one of the wooden posts, roughly the size of a walnut, pale brown, slightly papery at the surface, with a ridged, almost corrugated texture that made it look like some kind of dried seed casing or a piece of bark that had come loose in the wrong shape. You pulled it off without slowing down. It came away cleanly, all in one piece, and you threw it into the pile with everything else without ever once wondering what was inside. Stop. What you just removed from that fence post was not a seed case. It was not debris. It was not anything that belonged in your pile of garden waste. It was an ootheca, the egg case of a praying mantis, and inside it, arranged in rows of sealed chambers that her body engineered last autumn with a precision that materials scientists have only recently begun to understand, there were between 100 and 200 individual eggs, each one suspended in a state of chemical patience, waiting for a single specific signal from the world outside. The signal they were waiting for was warmth, your warmth, the warmth of a spring that was already arriving. You removed them before it could reach them. Let's start with what that structure actually is, because the material it is made of should stop anyone who understands it from ever treating it as disposable. When a female praying mantis lays her eggs in autumn, she does not simply deposit them and leave. She produces a liquid foam from glands in her abdomen, spinning her body in a rhythmic motion as she extrudes it, whipping the foam into a layered, aerated matrix that hardens on contact with air into a structure researchers have spent years trying to fully characterize. The outer surface of a finished ootheca is tough, slightly spongy, and water-resistant, but what is happening inside is more remarkable than the exterior suggests. The foam matrix is not uniform. It is a graded architecture, denser at the outer layers where it needs to resist moisture and temperature extremes, and progressively more porous toward the center where the eggs are held, creating a thermal buffering system that keeps the interior temperature significantly more stable than the surrounding environment. Laboratory tests on ootheca samples have documented survival of intact egg cases at temperatures as low as -30°C, a cold tolerance that far exceeds what the eggs themselves could survive if exposed directly. The structure she built around her eggs is not simply a container. It is an insulated vault, engineered without tools, by a single animal, in a single overnight session, using nothing but her own body and the precise movements of her abdomen in the hours before winter arrived. I remember reading a description of this foam spinning behavior in detail for the first time, the way the female rotates her abdomen methodically while working, the way the chambers are formed layer by layer within the structure, and having to set the reading aside because it was too difficult to reconcile the precision of the process with the casualness with which most people, including me for most of my life, treat these objects when they find them on a fence post. Let that settle for a moment. That walnut-sized thing you pulled off the wood this morning was the result of hours of highly coordinated biological manufacturing, producing a structure that maintains a viable microclimate for 6 months through rain, frost, and temperature swings that would kill unprotected eggs within hours. You threw it in the compost pile. Inside that ootheca, the eggs are not simply sitting in foam. They are arranged in precise bilateral rows within sealed inner chambers, each egg held in a separate cell, each cell separated by thin foam partitions that maintain humidity and oxygen flow around each developing embryo individually. The total number depends on the species and the size of the female, but for the most common garden mantis species in North America and Europe, a single ootheca typically contains between 100 and 200 eggs. All of them viable. All of them waiting. The development inside each egg is suspended in a state of diapause, the same metabolic pause that spider eggs use, a biological countdown held frozen until the thermal cues of spring cross a precise threshold. What that means in practical terms is that every ootheca on your fence, your garden stakes, your dead flower stems, your dormant rosebush canes, is a sealed package of waiting life, and the only thing standing between that life and the garden is the temperature of the air around it and the question of whether the structure is still there when that temperature arrives. Now here is the part of the story I want you to hold on to, because it changes what you are actually looking at when you see one of these cases in your garden. What emerges from a single ootheca on a warm spring morning is not a gradual, quiet process. It is sudden. The nymphs, pale and translucent, barely a centimeter long, begin emerging from between the foam layers almost simultaneously, dozens of them within minutes of each other, hanging from fine silk threads as their legs and antennae harden in the air. They are perfect miniatures of the adult form, with the distinctive folded forelegs already held in the classic predatory posture, which is the posture they were born into and the only posture they will ever use to catch prey for the rest of their lives. And then, in the minutes that follow the emergence, something happens that most field guides mention briefly and that most people, if they knew about it, would find difficult to watch and impossible to forget. The nymphs begin to eat each other. Not all of them, and not randomly, but the weakest individuals, the ones slowest to harden, slowest to move, are consumed by the ones who emerged faster and stronger. It is not cruelty in any sense the word usually implies. It is the most efficient possible quality filter in an animal whose entire adult existence depends on the precision and speed of its strike. The mantises that survive the first 10 minutes of their lives in your garden are, by definition, the fastest and most capable hunters that ootheca will ever produce. They are also, by the same logic, the ones who will spend the rest of the season removing the caterpillars, aphids, beetles, moths, and flies from your plants with a predatory efficiency that no product you can buy from a garden center approaches. A single mantis that survives to adulthood will consume several hundred insects over the course of a season, hunting by sight, during the day, precisely where you most want something hunting. And every one of them began in a walnut-sized foam case attached to a fence post you were about to clear. But before any of this happens, before the spring emergence and the first hunt and the slow growth through summer, there is a scene that belongs to the autumn, to the last days of the female's life, and it deserves a moment here because it explains why the ootheca ends up exactly where you find it. A female praying mantis choosing an oviposition site does not do so randomly. She walks the available structures in her environment, touching surfaces with her forelegs and antennae, assessing substrate texture, height, solar exposure, and proximity to vegetation where her nymphs will find their first prey. The sites she selects tend to be elevated, away from ground moisture, positioned on the south or southwest face of vertical surfaces that will receive direct morning sun in spring, the exact orientation most likely to deliver the thermal warming signal that will trigger emergence. She is not acting on memory or learned preference. She is following a sensory assessment protocol that evolution has refined over 300 million years of mantis reproduction, and the result is a placement so reliably optimal that researchers studying mantis population dynamics use ootheca location as a proxy for microhabitat quality. The fence post she chose in your garden, the stem she selected in your flower bed, was not random. It was the best available option she could find after a survey of your entire garden. Which means that the ootheca you removed this morning was, in the most precise possible sense, your garden's own judgment about where its next generation of predators should begin. So what should you do the next time you find one of these cases while clearing your garden in late autumn or early winter? The answer is the same one that applies to every extraordinary structure this community has learned to recognize: look before you touch. An ootheca is firm, slightly spongy, uniformly pale brown, and firmly attached to whatever surface the female chose, often a woody stem, a fence post, or a garden stake positioned several feet above ground level. If you find one and the location genuinely needs to be cleared, do not pull it off and throw it away. Detach it carefully, attach or place it in a sheltered outdoor location at a similar height, in a position that will still receive the spring warmth it is waiting for, and leave it. The ootheca does not need to be in its original location. It needs to be undisturbed and within reach of the temperature signal it has been waiting months to receive. What you should never do is treat it as debris. Not because the female mantis will return, she will not, she almost certainly did not survive the winter. But because what she left behind on that fence post, the result of the last hours of her life, is the only thing her season produced that matters to your garden. 170 eggs, sealed in a foam vault that survived winter, waiting for the morning when the air is warm enough to begin. Leave them that morning. And the next time you are clearing fence lines in early spring and you find one still in place, still firm, still sealed, stop for a moment before the gloves come off it. Inside it, the countdown is already running. Have you ever found an ootheca on a fence post or a garden stem and wondered what it was, or watched mantis nymphs emerge in spring? Tell me about it in the comments below. I read every single one, and this is exactly the kind of observation this community was built around. And if you want to understand another structure in your garden that looks like nothing and contains something extraordinary, one that your garden produced entirely on its own, the next video is already waiting for you.